All right, so we had said fossil fuels are really nothing more than the product of ancient photosynthesis. And so I'd said like the main product of photosynthesis is a sugar, and that's what we have drawn here, C6H12O6. Now that molecule can be modified into other molecules, put together a bit differently, as like wood, cellulose. But that's the starting point. And carbohydrates, which are what are found in living plants and in human and in animals as well, they always have this formula of 2 to 1 hydrogens to oxygens. So you have 6 carbons, 12 hydrogens, and 6 oxygens. Well, what happens when you have those plant materials and they get buried underground and pushed down? They're exposed to very high pressure and high temperature. I like to watch some of these PBS TV shows, and I remember watching one where they were in one of the deepest, or I guess the deepest mine in the world in South Africa, and it was smoking hot down there. It would almost burn them. They were, 14,000 feet deep or some horrible distance underground, but it was super hot there. So the further you go underground, the hotter it gets. And so this plant material that gets buried underground and has all this rock pressing down on it, is being exposed to high pressure and heat. And what's going to happen is it's going to lose a lot of its oxygen. It's over millions of years. And so this is kind of interesting. You probably haven't ever seen the chemical formula for coal. But if we think of, here, this is an example carbohydrate. Well, here's coal, 135 carbons, 96 hydrogens, 9 oxygens. We said it loses oxygen. And then we have nitrogen and sulfur. So it has some of these other molecules that are present in life. And so what happens when we think about that original formula that I'd said, in the presence of oxygen with this fuel, you can then release the energy in it and produce CO2 and water. Well, what happens when you burn this, there's a lot more energy in it than is in the wood right here. So coal is formed underground and it loses oxygen, but it has 40% more kinetic or potential, 40% more potential energy than wood does. So that's why we like it. And when you look at, there's all the different kinds of coal out there, and there's the soft coals and the hard coal. And I remember when I was a kid, they said, oh, the best coal was this hard anthracite coal, which is present in eastern parts of Pennsylvania. But then as an adult, I found out that no, you can't, they don't even mine it anymore. It's very hard to mine because it's really hard. I mean, it's a very solid, rigid, hard material. But anyway, it's a cleaner coal than the soft coal. Now, what happens, what did we say was one of the drawbacks to, when we talked about pollution? We had said, when we burn coal, we produce acid rain. We had said sulfur dioxide and nitrogen dioxide. That's these molecules here. They form oxides. Okay, so it all started out. You might wonder, well, how did we get started doing this, burning coal? And I remember talking to some people who live down in West Virginia, and they said, what would happen is the people living back in the mountains there, they'd see coal on the side of a cliff, and they'd start chipping out the coal because it has 40% more energy than wood, so they could get more heat out of it. And then what do? You end up getting further and further in, you start chipping away at the wall, and you've got a deep mine. You know, you're working your way underground. Um, we started doing that, and then nowadays, if you say, and this is considered an environmental disaster by environment, people who are concerned about the environment, they've now gotten to where they just say, no, we're not going to dig underground because you got the problems of the ceiling falling on you and all of that. They just remove the top of the mountain. It's a bad idea, but it's a very efficient way to get the coal. The problem is you're left with this, what used to be a beautiful mountain, and it's now subsoil, and nothing will even grow on it. And so that's a whole different discussion. So anyway, we have stuff that is pollutants that are sort of a downside to using this as a byproduct. Now, one of the things I can do is you can remove and capture some of this stuff. As I said, I know before I've said that my father worked in clean coal when I was growing up, and they would wash away the sulfur and capture the nitrogen. But then you've got to do something with that ash as well. So there's ways of capturing all of that stuff. All right, so I'm going to stop here, and we'll talk about oil for a few minutes on the next one.